Have you ever wished you could travel back in time to witness historic events? Or leap into the future to see what awaits? Today, we're diving into one of humanity's greatest fantasies. Time travel. Is it possible? And if not, why? Let's explore. What would you do if time travel were possible? Comment below. Time travel has been a staple in science fiction for decades, from Back to the Future to Doctor Who. But what exactly do we mean by time travel? Essentially, it's the concept of moving between different points in time, similar to how we move through space. There are two types of time travel: traveling to the past and traveling to the future. But is either of these truly possible? Before we dive deeper, I want to know, if time travel were possible, what period would you visit and why? Share your thoughts in the comments below. Let's start with the science. According to Einstein's theory of general relativity, time and space are interconnected in what's called space-time. This theory has fascinating implications for time travel. Time travel to the future is not only possible, but has already been demonstrated. Astronauts on the International Space Station experience time slightly slower than we do on Earth due to their high velocity, a phenomenon known as time dilation. In fact, when astronauts return to Earth, they have aged a tiny bit less than people who stayed behind. This effect, though minuscule at the speeds and durations we currently achieve, has been proven by experiments. Would you like to travel to the future or the past? Let us know in the comments. But what about traveling to the past? This is where things get tricky. Some solutions to Einstein's equations suggest the possibility of wormholes, or tunnels through space-time, which could theoretically allow travel to the past. However, this would require exotic matter with negative energy density, something we haven't found in the universe. Moreover, even if wormholes exist, they would likely be unstable and collapse before anyone could travel through them. And then there's the famous grandfather paradox. If you traveled back in time and prevented your grandparents from meeting, would you still exist to make the journey? These paradoxes create significant logical issues. It's not just the paradoxes. The energy requirements for creating and maintaining a wormhole are astronomical. We're talking about the energy equivalent to an exploding star, far beyond our current capabilities. Some modern theories in quantum mechanics also touch on the concept of time travel. Quantum entanglement and superposition hint at strange connections across time and space. But these phenomena don't translate to practical time travel. There's also the many worlds interpretation, which suggests that every possible outcome of a quantum decision occurs in a separate, parallel universe. This could mean that traveling back in time would create a new timeline, not alter the existing one. Fascinating, but still beyond our reach. Do you believe in parallel universes? Share your thoughts. So, where does that leave us today? While time dilation proves that time travel to the future is theoretically possible, practical and significant travel remains beyond our reach. As for traveling to the past, the scientific consensus is that it's impossible with our current understanding and technology. So, where does that leave us today? While time dilation proves that time travel to the future is theoretically possible, practical and significant travel remains beyond our reach. As for traveling to the past, the scientific consensus is that it's impossible with our current understanding and technology. However, the progress in technology and physics over the last century has been astounding. Who knows what discoveries await us in the next 100 years? Maybe one day, time travel will shift from the realm of science fiction to science fact. Do you think we'll ever solve the mysteries of time travel? Share your thoughts below. Let's not forget the ethical and philosophical implications of time travel. If it were possible, who would control it? Could altering the past have unforeseen consequences? How would society handle the power to change history? These questions remind us that even if time travel were possible, it wouldn't be without its challenges. The potential for misuse and the impact on the fabric of reality itself are concerns that we would need to address carefully. What ethical issues do you think time travel would raise? Comment below. The renowned physicist Stephen Hawking proposed the chronology protection conjecture, which suggests that the laws of physics prevent time travel on a macroscopic scale. According to this conjecture, the universe forbids closed time-like curves, which are paths in space-time that loop back on themselves. Hawking's idea is that nature has built-in mechanisms to prevent the paradoxes and inconsistencies that time travel would create. This means that while certain solutions in general relativity might suggest the possibility of time loop, the physical universe conspires to prevent them. This conjecture adds another layer to the impossibility of practical time travel, reinforcing the idea that even if mathematical solutions exist, real-world constraints keep time travel out of our reach. Kurt Gödel, another prominent physicist proposed a solution to Einstein's equations known as Gödel's universe. This model of the universe is rotating and allows for closed time-like curves, theoretically enabling time travel. However, Gödel's universe is highly theoretical and does not match our observations of the real universe. The rotation required for such a model is not something we observe in our cosmic background radiation or the large-scale structure of the universe. While Gödel's work is fascinating and contributes to our understanding of relativity, it doesn't provide a practical roadmap to building a time machine. Another intriguing concept is the Tipler cylinder, proposed by physicist Frank J. Tipler. This theoretical device involves a massive, infinitely long cylinder that rotates rapidly. According to Tipler, this rotation could create closed, time-like curves around the cylinder, allowing for time travel. However, the requirements for this device are far beyond our current technological capability. The cylinder would need to be infinitely long, or at least very large, and the energy required to rotate it at the necessary speeds is astronomical. Like many other time travel theories, the Tipler cylinder remains a fascinating but impractical idea with our current understanding and resources. In conclusion, while time travel captivates our imaginations and has a basis in scientific theory, practical time travel remains out of reach. From the energy requirements to the logical paradoxes and the fundamental laws of physics, numerous barriers prevent us from moving freely through time. If you enjoyed this video, hit the like button, subscribe for more fascinating content, and don't forget to comment below with your thoughts on time travel. Until next time, keep exploring the past.